For such wonderful presentation regarding design, let's dive deep into the muddy sea of video content protection. Okay, now starting with the basics. All of you know that you can download any kind of content, video, audio, and books somewhere in the internet from the pirate sites. But actually, if you want to live in a legal world, and I know you won't, so you have to avoid the piracy, and this is the requirements from the content owners. So let's try to understand how to create players and what is the content protection at all. So the main reason that's yeah okay so content owners requires to use DRMs, digital right management systems, and this is a kind of ecosystem that should be robust and protected, and you should have your video files protected and encrypted, and to provide to the users a key to decrypt it and unprotect on the device and in the player. So very fast, what are usually inside is video files that is encrypted, because most of them are provided and distributed in different networks. They have different bit rates of video streams to be good, to have good playback in different quality of networks, and it also can have some different audio tracks, subtitles, and so on. And for encryption, it's encrypted with AES-128 algorithm. Okay, this what is adaptive streaming meaning. So what is the reason to store several bit rates inside one video file? So some bandwidth detection model detects the quality of network and select the chunk that is best for current network conditions. And as a result, you have smooth playback without interruptions, but with slight quality changes. Okay, now let's protect this kind of content. So encryption is not enough, because this is not what major studios are required. So you have to add something more. So this is a license key. The license itself that consists of key and the rules, and you should store these keys inside some secure storage and avoid license requests outside to be inside the player, and you also should have secure infrastructure. Okay, a bit more specific, what is the license to unprotect the video you paid for? So the license is the key and the rules, and the rules can be different. So it can be transactional rules like download to own and or rental, and it can be subscription rules. So when you're paying every month or every half of a year or so on. Other differentiations is online and offline protections. So the main reason and the main platforms you can have offline is where you have secure clock, because no one wants that you set your clock back in time and get your video forever, get your license forever. And such offline playback, you store your downloaded content as well as license on your device. For example, in browser it can be IndexedDB. And sometimes this secure place is not inside the software platform, but inside the hardware system on chip on the device. For the browsers, as you can imagine, it's not impossible, but it's impossible on the Chrome on Android. But in general, on browser platforms, this is a software content decryption model, like it's called. And if you have a hardware content decryption model, it means that this secure places is integrated on the firmware and during manufacturing process. So, and after it you have some kind of API that gives you ability to get these keys from the trusted execution environment. Okay, software DRM, when you have all your keys inside the secured key box in the software, and unprotected video also goes through the software. Making it more secure, it can be when you are storing your keys inside the trusted execution environment in the chip, but your unprotected video is still goes through the unsecure way with software to the screen. And the most secure way, when all these parts are protected, so only on the screen the unprotected video is rendering. So you obtain the license, store it in the content encryption model, obtain the license, store it in the hardware secure place, decrypt it inside this hardware trusted environment, and render it to the screen. And different requirements from the studios appear when you have to play different qualities of the video. So the main thing here that you should remember that you cannot play 4K content inside your browser legally. Okay, let's continue to the systems, digital right management systems. And at the beginning it was so-called classic DRM systems. So different DRM providers obtain approvals from the studios, and there were a lot of different video files, protected video files formats. For example, for Widevine, that is now Google, one huge file with all bit rates. For PlayReady, their own protected Microsoft manifest, and for others, same thing. Now the world became much simpler, a bit. It's called Modular DRM systems. It's based on industry standards like dynamic adaptive HTTP streaming, common encryption, browser extensions for media source and decrypted media, and still the content decryption model. Also, there are so-called PSSH boxes. This is unique DRM IDs that is stored inside manifest of the dash, and this gives you the ability to have several systems inside one manifest, because all of them regarding to common encryption standard are using AES 128. The beautiful thing here is clear case support. That means that you should not have any partners with Microsoft or Google or Apple, but you can test your player with the predefined key. And this clear key support is the part of all browser platforms. Okay, the main players here, the same companies you are dealing every day: Microsoft, Google, Apple, a bit of Adobe, but not so much. And the fragmentation is like here. So Microsoft Explorer 11, Edge are using PlayReady, and Chrome, Firefox, Operas, and Android mobiles are using Widevine, that is part of Google, and Safari and iOS devices are using FairPlay. On smart TVs, fragmentation is much bigger, so some of them are using only one system, some are using different, or both. Okay, if you know a bit of boring, let's remember this old Dilbert joke that all these DRM systems should add easy to use requirement for those lists. Okay, now let's go closer to the front end. This is a component flow, how DRM video protected files are used. So you have the video input, and you should package it in general with some keys, and distribute it with some content delivery network. Then you obtain from your player these protected files, try to get the license from license server, from the proxy, and provide all of this to the extensions in the browsers or some proprietary APIs. But in general, from the front-end point of view, we will cover only the media player, and it means that you just need the protected video file URL, license proxy URL, and maybe 3 of them for different systems, and you should provide all of this to the APIs of the browser or browser-like platform. Okay, let's go to the browsers. There are 2 extensions, media source extensions and encrypted media extensions. Media source extensions is extension of HTML media element and provide abilities to play audio and video inside your HTML page. And it's easy like that. So just create different type of codecs and sources and playbacks. And encrypted media extension, it's also gives the ability to HTML media element some extra APIs to deal with the encrypted content, getting the license, understand that the license is needed, and so on. And it's easy like that. So easy, you know. And in different browsers, there are different systems. So to support all the browsers, you have to implement several of them in your player. And how to do that? First of all, you should understand, does encrypted media extension is supported at all? Because if you have some old version of the browser, it's not there. So, and then you request what key systems are inside. Clear key should be there, but others cannot be. So you have to know these keys for the different systems. It's public and can be found easily. And you also can ask from MSC what codecs are supported, and you are done. But not so fast, because you have to implement this bitrate adaptive and so on. And from my point of view, that there's no reason to reinvent the wheel. You can just get different players that other people already implement. If your company is rich, so you can get the paid solutions. If not, however, you can get the open source players and make some fixes by your own. And here presented 4 good ones. For example, Shaka is provided by Google, and Rix Player, written in TypeScript, is provided by France Channel Plus. And when going to the supported DRM systems from the open source players' point of view, we can understand that for the Fairplay, so for Safari, only one of them support HLS with Fairplay, and others are not. So in Okko, we selected that we will use Shaka Player for all browsers and Google and Microsoft DRM, and for Safari we are using the reference modified reference player provided by Apple. When I'm going to front-end development for CE devices, smart TVs, this is real pain and suffering starting here. So as you can see, Widevine Classic is the old DRM with a proprietary type of file, and in Russia, from our statistics, about 70% of smart TVs still using this DRM system. For other CE devices, fragmentations is still big and there. So, for example, video game consoles having only PlayReady, and Apple TV, as you can imagine, having only Fairplay. So, how to deal with that? Okay, let's first understand what smart TV or what CE device you have. Let's try with Samsung. Okay, and what player and proprietary IP to use? Continue with LG. Okay, that's the real examples from our code. Video game consoles, Panasonic, Sony, and the masterpiece is Philips. I like it. Okay, so as a result of that, we have the bunch of JavaScript files to detect device capabilities and what is device is, and the bunch of players that are implementing proprietary APIs. So you can ask, where are these wonderful standards, IME and MSC? Actually, they are here in Samsung Smart TVs, but only since 2017 on Tizen platform. And it supports Dash and Senk and all this wonderful stuff. And it's also on LG Smart TV since 2016 on WebOS 4.0. So if you are going to implement the player supporting only these platforms, it's okay to get the Shaka or X player and use that. But if you necessary to support this wonderful Philips and Panasonic and so on, you have to deal with proprietary APIs and get this real nightmare. So, okay, some words about DRM in the world. As you know, Chrome and Firefox are the browsers with open source. And content providers, content owners, and businesses are trying to integrate, and already tried to integrate those private piece of black boxes into the open source code. And when in 2017 W3C consortium greenlighted to using IME inside all the browsers, this guy, the knight of the Free Software Foundation, Richard Stallman, you know, organized the movement that is called Defective by Design, and this movement makes some activities like let's cancel Netflix or so on. Fortunately not cancel Opera. Okay, and for now only one browser that is supporting download of its version without IME and content decryption model, without DRM, is the Firefox. And Chrome became defective by design since version 57. So about a year ago, I think. Okay, let's go to conclusions. Not about why DRM is defective by design, but about how to use it in Frontend. So, the conclusions are simple. Don't reinvent the wheel, but understand standards, what are inside those wonderful Shaka or RX players or other open source players that you can use. Try to avoid using proprietary APIs to defeat this fragmentation nightmare, and enjoy your coding. Thank you.
Thank you. Okay. Any questions? Who want to guess these cute dinosaurs?
Hi, thank you for a talk. It was really informative, and there was a lot of information I would really need to go deep into. So that was a lot of information, and I really wanted to know about your experience and your drawbacks of, as I understood, you really realized your player, your secure player, and I wanted to know about the drawbacks, not about the secureness, about the realization.
Okay, well, the question is, so about implementation, the player?
Yes.
Yeah, in our company we have the In browsers we have Shaka player, and for the Safari we're having our own player based on reference player from Apple.
And so you are using that player?
Yeah,
and,
open source, yeah.
So you've made some infrastructure for them?
No, just for the, actually, because I'm working in video service, so we have all service in the house. So all this protection video and so on. And the player is only the piece of the one of the clients. So we also have mobile clients, and they have other players, or SmartTV players have all these wonderful proprietary APIs implemented.
Okay, okay, I see. Thank you.
Okay, thank you.
Hi, thank you for your talk. Everything was new for me, and I have a very simple question. When you take data from server chunks, what will be in network in browser? What will I see if I will open network? You have a request, you get chunks.
Yeah, you get some regular HTTP GET range requests.
And you get chunks.
Yeah, chunk is a part of the video file, so you can observe HTTP GET for the bigger file, for example, get something .ts, or you can get this for this TS range request, where it's shown the range what part of this file is necessary to obtain.
So this chunk will be encrypted?
Yeah, it's encrypted, and
so
it is decrypted inside the browser.
So if I will open this chunk in like...
You will see nothing.
Thank you.
Just trash.
Thank you.
Hello, thank you for the talk. Did I get it right that if you use DRM in your browser on desktop, you decrypt your videos in software decoder, not in hardware decoder?
Sure, in software, yeah.
Okay, and another question. Did you measure performance impact of this? Because one, you need to decode your video in software, and the second one, you need to decrypt using encryption algorithm. So it should have some additional impact comparing to regular video that decoded through hardware decoder.
Yeah, I understand the question. I don't think we made any kind of tests comparing performance of unencrypted video playback and decrypted video playback, because from our point of view this is the only way to do that. But we observe a lot of problems on C devices. On browsers, I think it's not a problem. That's not the real problem, because you are not rendering around any kind of interfaces. You're just opening the video and watching it. Okay.
Oh, thank you for your report. And as I see, you support not only in browser app. I also can download application for iPhone and Android. But how do you decide what platform will you support on mobile? For example, is it efficient to support mobile Safari if it doesn't convenient and if it has really a lot of difficulty?
The goal is to support all platforms. This is the goal. But actually it's easy on mobile to move users to the native application, to give them more smooth user experience and video playback. But it's possible to play back encrypted video in Safari on mobile iOS.
Isn't it too expensive to support mobile on web?
Everything has a cost.
It's all? Who do you choose? Last question.
The last one.
Okay. It's you. And now break, 15 minutes.
Thank you.